you're about to see is what we all voted as the best social venture for energy. Now, just to remind you, for any of these social ventures, they could be a project, a nonprofit, a for-profit, or a fund. And we are extremely excited to welcome our winner of this year, which is going to be...
You want me to announce?
Go for it.
My print is bigger than your print.
Yes.
It is Cool Energy from Boulder.
Yes, Sam!
There you go. Thank you so much. Yes, you're in your picture. Thank you. You're welcome.
I want to say thank you to Colorado Impact Days for hosting this whole event and for selecting us. Our team has worked very hard, and it's great to get some validation and recognition for the work that we've done. So thank you again for this. Again, my name is Sam Weaver. I'm the CEO of Cool Energy, and I'm here today to introduce you to our breakthrough clean power generation devices that our team has put together in Boulder. And you will see this slide again later in the talk. I'll start with a reporter-style overview of Cool Energy. My father and I founded it in 2006, and we've become a team of hands-on design, build, test engineers and business development folks who are dedicated to advancing clean energy solutions. Over the last 10 years, we've taken a 200-year-old idea, the Stirling engine, and we've applied modern computational techniques and advanced materials to build a machine that turns wasted heat into clean electricity. We live and work in Boulder, and what motivates us every day is the fact that the world needs clean energy solutions badly. Clean tech advances are not going to be one silver bullet, they're going to be silver buckshot, and we're pleased to be part of the biggest business opportunity in human history. We have built 5 generations of this thermo-hard engine, and the current one is the most powerful and efficient yet. Let me show you more. So I'm trained as an engineer, so I can't help but put a chart up, but this is the only one that you're going to have to look at today. What's shown here is the blue line is the curve fit for the efficiency of current technologies at turning heat into electricity. And the red line is our measured results from our 5th gen engines. And in this case, higher is better. So our engines are the most efficient devices at turning low temperature heat into electricity ever invented. And what that means is that for a given low temperature heat source, we can make more electricity than any other possible method. Let me show you some of the sources that produce heat that we can turn into clean electricity. You see there a diesel generator, a natural gas generator, ship engines, pollution control equipment, oil field equipment, and a coffee roaster on the right. All of these and more we can use to generate clean electricity with. So let's look at the coffee roasting example as one example. It seems to be coming on pretty quickly. The coffee roasting community shares a lot of the same values we do as far as sustainability and triple bottom line accounting, and so we think our next sale is going to be to a coffee roaster in Portland, Oregon. And if you look at the diagram up there, you'll see us on the far right. We're the blue machine. We're grabbing the heat out of the exhaust air that would otherwise just be wasted out of this building. We're making enough electricity to power that entire facility. And so we really look forward to getting that installation done. According to one of our national energy labs, 20 to 50% of all industrial energy is wasted up exhaust stacks. We think this is a staggering missed opportunity, particularly because the temperatures and flow rates aren't enough to support steam turbine power generations. If we did even a fraction of these heat recovery opportunities, we could prevent the need for 30 additional power plants in the United States. Our products are aimed directly at this market, and it's estimated that the market size will be $53 billion by 2018, and we look forward to being part of that growth curve. Let me show you how our machine operates. So to begin with, we hook our machine up to a source of exhaust gas. In this example, it's a diesel generator. That exhaust gas passes through a heat exchanger. It heats a fluid. That fluid circulates into our engine. The heat's delivered into the engine where it's turned into clean electricity. That electricity goes out on the customer side of the meter, which meets their energy needs and reduces their electrical bills. These engines are modular, so if the heat source that we've got is more than one engine can handle, you can use 2 or 5 or 10 engines as is shown in this slide. So there's a lot of public benefits from a widespread deployment of the Thermohard engine, and we think that the potential upside is even bigger than the national labs think so. By our math, if we were to get to the best 30% of sites that are appropriate for our engine scale, we could avoid 20 power plants construction in the United States. Each one of our engines is powerful enough to power about 20 homes or one medium-sized business. Oh, in the process of avoiding that and powering all those businesses and homes, we would avoid 25 million tons of emitted carbon dioxide every year. Our business model is designed to be capital light. Other companies have built their specialties on doing high efficiency manufacturing, and others still distribute those products that I showed you that we can recover waste heat from. So we're going to focus on what we do best and partner with people who are good at what they do best. Our first contract manufacturing partner is Keller Technologies Corporation out of North Carolina, and our first customer and distribution partner is Edison Heliostats out of Pasadena, California. So here's the ask. We're actively raising capital right now, and we're fundraising based on the strengths of sustained business and technology progress to date. This effort has taken about $10 million over the last 10 years, and the source of funds have been customer sales, venture investment from Idea Lab, individual investors, and grants that we've raised from the National Science Foundation, the Department of Energy, and the Environmental Protection Agency. We've protected our intellectual property vigorously. We have 8 issued patents, and we have 3 which are pending. We hope that you see the value in what we're doing, and we hope to hear from you if you think there's a possible partnership or investment that we can make work together. So finally, here we are, we're right back where we started. I took this picture when I was attending a coffee trade show in Seattle. That is the picture, that's the growth rather, of the Starbucks boutique roastery that's just uphill from the Seattle Convention Center. And if you look at the heat shimmer that's coming out of those 2 stacks, that's coming off their roasting operation. If we were to capture the heat coming off of that, up those stacks, we would be able to more than power that facility's electrical needs. Someday, that's exactly what we intend to do there and at 400,000 other sites across the United States. Thank you so much.